everybody. So the next lesson that we are going to cover in our real numbers and exponents unit leads us to a lesson about squares and square roots. In your textbook, this would be lesson 10.1. You're definitely going to want a calculator and some paper for notes. And let's get talking about what are squares and what are square roots. So in math, when we talk about taking a number and squaring it, what we really mean by that, take for example 5. If I talk about squaring 5, what I really mean by that is 5 to the second power. If I were to really draw this out for you, think of a square that is 5 units in length and 5 units in width, so it makes a perfect square. So the length on this side is 5, and the length on this side is 5. And if we were to divide this up into little squares, or imagine 5 little rows, there's 5, and there's 5, and you were to count those squares, guess how many there would be? Well, 5 to the second power, otherwise known as 5 squared, is 25. There would be 25 of these little boxes if you were to count them. So this is really what we mean. When we call something squared, or we say that a number is 5 squared or 10 squared, we mean a length of 10 and a width of 10. And imagine a design that big, and then you were to count all the boxes inside. But mathematically, 5 to the second power, 5 squared, just means 5 times 5, and the answer is 25. Okay, so this is kind of what we're talking about today. So this answer that I just got, this 25, that has a name. That's called a perfect square. So, this first definition here, a perfect square is a number that is the square of an integer. So here down below in red, I've listed the first, looks like the first 10 perfect squares, right? 1 is a perfect square because that's the answer you get for 1 to the second power. 4 is a perfect square because that is the answer you get for 2 to the second power. This one is 3 to the second power, 4 to the second power, and so on and so forth. These are the first 10 perfect squares. So the perfect squares are 1, 4, 9, 16, 25, 36, 49, 64, 81, 100. And you could keep going. You could 11 squared, 12 squared, 13 squared, and so on and so forth. But the answers that you get are called perfect squares. Okay, so then what is a square root? Well, a square root is kind of when you think backwards. It's when you start with a perfect square and you ask yourself what number was to the second power to get me to that answer. So, the definition. A square root is one of the two equal factors of a perfect square. That can be confusing. So in my words it says, the integer that was squared to get the perfect square. So if I ask you what the square root of 25 is, you kind of need to think backwards and ask yourself, what number to the second power equals 25? Okay, and then you think, oh, that's 5, right? 5 to the second power equals 25. So we say that the square root of 25 is 5, right there. It's not 5 squared, it's just the 5. And, of course, there's a symbol in math for finding the square root of a number. It's called the radical sign, and it looks like this. The computer doesn't type it very well. It really has kind of a top on it. So the radical sign looks like, if I were to draw it, I would draw it like that. That's the radical sign. And if you see that, and you see a number inside, that means we're finding the square root of that number. What number to the second power equals 25? What is the square root of 25? 5. That's the answer. Not 5 to the second power, just 5. So, let's practice some. Again, remember that, in a perfect world, these would all have these nice little tops on them. Let's talk about some of these answers. What is the square root of 49? Can you think in your head, what number to the second power equals 49? Doop-de-doop-de-doo. I hope you're good at your times tables. The answer is 7, because 7 squared is 49. Let's drop down to the next one. Negative the square root of 16. So I'm down here now, and I see that the negative symbol is outside to the left. That means we're going to stick a negative on our answer. So ask yourself, what number to the second power equals 16? Hopefully you thought of the answer, which is 4. But because there's that little negative sign out to the left of the radical symbol, that means you have to put a negative in your answer like so. So the answer here is negative 4. Because it's negative the square root of 16. The square root of 16 is 4, and the negative of that is negative 4. Let's go up to the right here. This one says the square root of negative 64. So think in your head, what number squared equals negative 64? What number times itself will give me negative 64? I bet you thought of negative 8. Did you say negative 8? Well, think about that. What is a negative 8 times a negative 8? A negative times a negative is a positive. Not negative 64. Do you realize this? Is not possible. There is no real number that when you multiply it by itself will give you a negative 64. We'll always end up with a positive 64. So there is no real number. And that's your answer. There is no real number times itself that will give you a negative 64. Okay, so we're going to say nothing, like so, right? Nothing squared will equal negative 64. Not 0, but nothing at all. And then the last one we have here says positive and negative, right? That's what this little symbol means. We want the positive and the negative version of the square root of 100. What's the square root of 100? What squared is 100? I hope you know it's 10, right? So the answer isn't just 10. You have to show that you're finding the positive and the negative versions. So it's positive and negative 10. Because the positive and the negative are outside of the radical sign. If the negative is inside the radical sign, as it was up here, that spells trouble and you can't solve those problems. Next up is estimating square roots. This isn't too bad. If they ask you to find the square root of a number that's not a perfect square, you have to estimate it. So they give us one. They tell us to estimate the square root of 22. Well, there is no whole number times itself that equals 22. So think of the perfect squares that 22 comes between. Go back to that list maybe on the first page. 16 and 25 are perfect squares, right? This is 4 squared. This is 5 squared. And somewhere in between there is the number 22. So now you have to ask yourself, 22 is closest to what? Is it closer to the 16 or is it closer to the 25 if you were to be counting? Well, let's see. 22 is 4 away from 16. And 22 is only 3 away from 25. So I'm going to say this is closest to 25. So the square root of 22 is about the square root of 25, and that answer is 5. So that's how we estimate square roots. So let's try some. What do you think about 60? Well, think of what 60 comes in between. 60 comes in between 7 squared, which is 49, and 8 squared, which is 64. Which is it closest to? Obviously, closest to this. So we're going to say that the square root of 60 is about the square root of 64, which is 8. How about negative the square root of 23? Okay, what's it in between? What's in between these two? That's 4. That's 5. What's it closest to? Closest to this. So, negative the square root of 23 is about negative 5. And then the very last examples are really easy because they ask you to use a calculator. And it says, round your, hey, come back here, to the nearest tenth. So these you just literally get to punch in your calculator. So you type in the square root of 14 and you round it. Using a calculator, you should get 3.7. Make sure you can make that happen. Square root of 40 on a calculator is 6.3 after you round it. Couple more and then we're done. Negative the square root of 79. Okay, so in your calculator, find the square root of 79, round it, and don't forget to stick that negative on there. Look at this next one. The square root of 67, when you round it, is 8.2. But it tells us to find both the positive and the negative of that. So that's what you write your answer as. Plus and minus, or positive and negative, 8.2. So there's two different ways that we estimate square roots. We can do it using a calculator, or, as we did above, we can estimate them by looking at other perfect squares and figuring out which it comes closest to. Oh, there's the bell. Just in time, too. This is the assignment we'll be working on in class, and I'll see you then. Bye, guys.